Hello, this is Akhilesh Kumar Singh, Assistant Professor, IIMT College of Engineering, Greater Noida. My live lecture on CPU scheduling in operating system. Content, my content is basic concepts of scheduling, CPU, scheduling criteria, types of scheduling algorithm, terminology used, first come first serve scheduling, shortest job first scheduling, shortest remaining time first scheduling, and priority scheduling, and last one is round robin scheduling. Basic concepts of CPU scheduling is CPU scheduling is the process of determining which process will on CPU for execution while another process is on hold in a ready queue. And the main task of CPU scheduling is to make sure that whenever the CPU remains idle, that is CPU is not in working conditions. That is CPU in rest positions. The operating system list select one of the process available in the ready queue for the executions. The selection process will carried out by the CPU scheduler. It select one process in the memory that are ready for executions. Scheduling criteria. There are different scheduling criteria available. First one is CPU utilization. We keep the CPU as busy as possible. Next one is throughput. Throughput is the number of processes that complete their execution per unit of time. Next one is turnaround time. Total amount of time to execute a particular process is known as turnaround time. The waiting next one is waiting time. The amount of time that a process has been waiting in ready queue is known as waiting time. Next one is response time, amount of time it takes from when a request was submitted until the first response is produced, not the final. Next one is types of scheduling algorithm. There are basically two types of scheduling algorithm in operating systems. First one is non-primitive scheduling algorithm. In a non-primitive scheduling algorithm, if one process start the execution in the operating systems, then it will fully execute. That is, no context switching is allowed here. Next one is primitive scheduling approach. In this approach, operating system, the resources to a process for a predetermined period of time. That is, for each process, we allot a time slice or a time quantum. For that time quantum, it execute and then print by the operating system, and that in that period another process will arrive in the CPU for the executions. Terminology used in the CPU scheduling: arrival time. Arrival time at time at which the process arrive in the ready queue is known as arrival time, and next one is completion time. Time at which process completes its execution is known as completion time. Burst time, the execution time of the process in the CPU is known as burst time. Next one is turnaround time. The time difference between completion time and arrival time is known as turnaround time. Waiting time. Next one is waiting time. We calculate the waiting time. It is the difference between the turnaround time and the burst time is known as waiting time. Now we discuss the first CPU scheduling algorithm. First come first serve algorithm. In first come first serve algorithm, we take number of processes. There is three available processes, and the burst time is given. For process P1, burst time is 24, and for process P2, the burst time is 3, and process P3, the burst time is also 3. Suppose that the processes are arrived in order P1, P2, and P3. Now we prepared a Gantt chart for, for the process executing in first come first serve manner. In first come first serve algorithm, uh, which process arrived first will execute first in the operating systems. Here all the process here all the process arrive in ready queue at time t equal to 0. So process P1 will execute first at a time t equal to 0. Process P1 will execute for burst time 24. And for process P2, their burst time is 3. Then process P2 will execute from 24 to 27. Now process 3 will execute for burst time 3. Now we calculate the waiting time for each process. For process P1, it arrived in ready queue at a time t equal to 0. So execution will start at a time t equal to 0. So waiting time for process P1 is equal to 0. And process P2 arrive at a time t equal to 0 and their execution start at time t equal to 24. So process P2 will wait 24 time unit in ready queue. So waiting time for process P2 is 24 and process P3 arrive at a time t equal to 0 and execution is start at time t equal to 27 milliseconds. So the average time waiting time is we add each waiting time here 0 and plus 24 plus 27. We add the each waiting time of each process and divide by total number of process available. So the average waiting time is 17. Now we go for the next scheduling algorithm. Second algorithm is shortest job first algorithm. Here we execute those process first which has less burst time. Here process P1 has its burst time is 6 and process P2 has its burst time is 8 and process P3 has its burst time is 7 and process P4 has its burst time is 3. So process P4 has minimum burst time in a given process. So we will start the execution of process P4 firstly. And now we execute process P4 for 3 unit of time. Then we execute process P1 and then P3 and then P2. We prepared a Gantt chart according to the shortest job first scheduling here. Then we calculate the waiting time for each process arrived in shortest job first manner. Now for process P1, waiting time process P1, all the process arrived in ready queue at a time t equal to 0 and the process P1 will start its execution at a time t equal to 3 Waiting time for process P1 is 3 milliseconds, and for process P2 is 16 milliseconds, and process P4 process P4 arrived first and execute first. So process P4 has its waiting time is 0, and process P3 has its waiting time is 9 milliseconds. Because all the process arrived in ready queue at a time t equal to 0 milliseconds. So the average waiting time is the additions of all waiting time of each process and divide by total number of process. Now we understand the next algorithm. Next algorithm is shortest remaining time first. Shortest remaining time first algorithm. This algorithm is a primitive type of algorithm for CPU scheduling. Let's process P1 has arrived at time t equal to 0, and its burst time is 8 milliseconds, and process P2 is arrived 1 millisecond at time t equal to 1 millisecond, and its burst time is 4 milliseconds. And now process P3 arrived at time t equal to 2 milliseconds, and its burst time is 9 milliseconds. And process P4 has its arrival time is 3 milliseconds, and its burst time is 5 milliseconds. Now we prepared the Gantt chart for each process. In ready queue, process P1 arrived at time t equal to 0 millisecond. And execution is start at time t equal to 0 milliseconds. No other process are available in the ready queue, so we execute the process P1 at a time t equal to 1 millisecond. Process P2 is arrived, and process P1 execute only one time, 1 unit of time. So yes, 7 time unit is remaining, and now process P2 has its burst time less than the process P1 burst time. So process P2 will be executed firstly for time t equal to 1 millisecond to 5 milliseconds. Now all the process during that time, all the process is arrived in the ready queue. So we find which process has least burst time. Then now process P4 will execute, because process P4 has its burst time is 5 millisecond. Now process P1 will execute because its burst time is 7 millisecond, which is less than that of P3 burst times. Now last one is P3 will execute. Here the Gantt chart is given. Now we calculate the waiting time for each process: process P1, process P2, and process P3, and process P4. Process P1 has initially its waiting time here is process P1 waiting time is 0, and here process P1 wait for 10 minus 1, 10 minus 1, that is 9 millisecond. And now process P2 arrived at a time t equal to 0 millisecond, and its execution is start at time t equal to 1 millisecond. So their waiting time is 1 minus 1 equal to 0 millisecond. And process P3 arrived at time t equal to 2 millisecond, and their execution is start at 17 millisecond. That is 15 millisecond. It's waits in ready queue. Now last one is process P4. Process P4 arrived at time t equal to 3 millisecond, and their execution is start at time t equal to 5 millisecond. So their waiting time is 5 minus 3, that is 2 milliseconds. Now we calculate the average waiting time. That is, we add the waiting time of each process P1, P2, and P4. We find 26 by 4, and after calculation 6.5 millisecond there will be the waiting times. Now we go for the next algorithm. Next algorithm is priority scheduling algorithm. The priority scheduling algorithm is primitive as well as non-primitive scheduling algorithm, in which a priority is given in the form of integer and associated with each process. The CPU is allotted to a process with the highest priority. That is, if smaller the integer, highest will be the priority. Now take an example of priority scheduling. There is a 5. Here we take 5 processes, and their burst time is 10, 1, 2, 1, and 5. Now we decide the priority of each process. According to the priority of the process, we start the execution of the process in a running queue. Here arrival time is not given, so we taken that each process is arrived in the ready queue at a time t equal to 0 millisecond. Now all the process are ready for the executions, but we take the process for the execution which has higher priority. Process P2 has less value, so process P2 has higher the priority. So firstly we execute the process P2 in the execution queue for one time unit, because their burst time is 1 millisecond. So next process will be process P5, because their second priority is process P5. So we execute it for 5 unit of time. Now we execute process P1. Process P1 has its burst time is 10 unit of time. So we execute from 6 unit of time to 16 unit of time. Next process will be process P3. Their burst time is 2 milliseconds. So this is start from 16 unit of time to 18 unit of time, and now we lastly execute process P4. Now we calculate the waiting time for each process. So for process P1 arrived at time t equal to 0 millisecond. While all the process are arrived at time t equal to 0 millisecond, in ready queue. So process P1 has its waiting time is 6 milliseconds, because at a time t equal to 0 second, its arrival time and its execution time is 6 milliseconds. Now process P2 has its waiting time is 0 millisecond, because it arrived at time t equal to 0 second in ready queue, and execution is also stopped at time t equal to 0 millisecond. Now process P3 is arrived at time t equal to 0 second, and their waiting time is 16 millisecond, and process P4 has its waiting time is 18 millisecond. Now we find the average waiting time of each process. We add the waiting time of process P1, P2, P3, and P4, and we find 8.2 millisecond, the average waiting time. Now we go for the next algo. Next algorithm is round robin algorithm. In round robin algorithm, this is a primitive type of scheduling algorithm in which time quantum or time slice for each process is given. Each process gets a small unit of CPU time, is also known as time quantum. Usually the time quantum is between 10 to 100 milliseconds. After this time has elapsed, the process is permitted and other process is arrived in the ready queue for the executions. Now take an example for let's understand the numerical on the round robin algorithm. We take 3 processes and the burst time is 4, 3, and 5. And the time quantum is given is 2, that is if process that is each process has given 2 unit of time for the executions. That is, if process P1 arrived for execution, then it take 2 unit of time, and process P2 arrived in the CPU for the execution, then it also takes 2 unit of time. In this manner, we execute all the process. Firstly, process P1 arrived at time t equal to 0 milliseconds and start their execution for 2 unit of time. If we execute process P1 2 unit of time, then remaining time is 2 unit, and process P2 we executed. If process P2 execute 2 unit of time, then its remaining burst time is 1 milliseconds, and then process P1 execute again, then it's execute fully for remaining 2 units, and process P2 process P2 arrived and its remaining burst time is 1 millisecond, so it only execute 1 unit of time. Then now last one is process P3 arrived and it's execute 5 milliseconds. Firstly 2 unit execute, and then 2 units, and then 1 unit. Now we calculate the waiting time for each process. For process P1, initially process P1 has its waiting time is 0, and process P2 arrived at time t equal to 0 millisecond and start execution at time t equal to 2 millisecond. So there is waiting time here is 2, and again it's go for the waiting queue and wait till 8 milliseconds. So the waiting time is 8 minus 4, that is 4. Total waiting time is 6 milliseconds. And for process P3 start at time t equal to 4 milliseconds, arrived at time t equal to 0 millisecond. So waiting is total 4 milliseconds plus its waits for 9 milliseconds for the execution. So here waiting time is 9 minus 4, that is 5. 9 minus 6, sorry, 9 minus 6, that is 3 milliseconds. Total waiting time is 7 milliseconds. And average waiting time is 4 plus 6 plus 7, that is 17, divided by total number of process equal to 5.67 millisecond is their average waiting time. There is also some other scheduling algorithm is available in the operating system, like multi-level queue scheduling and multi-level feedback queue scheduling. But due to lack of time, I will discuss in the next video. Thank you.